Okay, welcome to our 10th week of Environmental Biology Online. Back to videos again. This week we start the topic of succession and disturbance. And we are going to do a little bit of reading to get grounded in the information. And so you'll read the Simutext chapter on community dynamics. So it's sections 1 and 4. It's our last Simutext reading. So you'll finish up that chapter. And then you'll do some work in the Critcher book. So you'll read the beginning of chapter 6. We've been reading parts of that. And that part emphasizes the two theorists, the two researchers, Clements and Gleason. So see if you can tease out who those two people are and what their ideas were, how they were different. And then you'll read chapter 7, which is definitely about succession, and then chapter 10, which is a little bit more, connects evolution and change over time. It's kind of interesting. And then in the discussion, I've come up with 4 discussion threads for us. And you'll post to one of those discussion threads. Each one is kind of covering a different topic. And inside each concept is 1 or 2 questions and maybe some bonus questions. So answer one of the questions, and I'd like to have us talk about all 4 concepts this week. So please choose a concept no one has talked about, just like always. And if you think there's something that you'd like to talk about that I didn't really address, then just add a new thread and talk about that. But make sure that your new post has examples, it references the text, and it shows that you're thinking and being critical and logical about the connections that you're making. So the other thing you need to do besides reading and discussion is work on the lab. So the lab this week is going to get us outside. So now that the weather is breaking, our labs will be outside. And you need to go outside and find 2 plants that still have some seeds on them. So it's a little tricky. They made seeds way in the fall and they've had to go through this whole winter. But when you look, you will find some plants that still have seeds. And here's an example right here. This is a plant that has really feathery seeds. So if you look really closely, you'll see little tiny hairs, and each one is attached to a seed. And what I want you to do for this lab is count all the seeds on this plant. And yeah, it's going to be a little tedious. But to make it easier, you can just look at one little section at a time. So when you look carefully at this plant, it's got all these little branchlets. And maybe you'll just take one branch and you'll count all the seeds on this one branch. And then you can multiply it out. You can multiply the number of seeds per branch times the number of branches on the whole plant. And then you'll get the number of seeds on the whole plant. You'll also look really closely at each seed and try to figure out the type of seed it is. And I gave some resources for that information. And you also want to measure the seed in some way. So that's probably using a ruler of some sort, and preferably use the metric scale on the ruler, the millimeters, to get a sense of how big those seeds are. And then you're going to do that to another plant. So here's a second plant right here. And when you look at this plant, you can see that this one has several different seed heads. So you want to make sure that you're not just counting one seed head, but all the seeds on the whole plant, where seeds seem to be missing. So you want to account for the seeds that are missing. Make sure you include that. Imagine in your head where you think the seeds may have been, and put those into the count. We want to make sure that we're counting all the seeds that the plant actually produces, not the seeds that might be left over at the end of winter. Now on this one as well, when I look really closely, I can see that the seeds have mostly fallen out of this plant. There's all these little cups, like they almost look like little flowers. There's like 6 or 8 sections that looks like used to hold seeds. And I can't really find any in there, but I could count to see how many little sections there were. And maybe if I imagine 1 seed per hole, that will really help. And you can probably also imagine how big they must have been to fit in those holes. So if you have to do some imagining and guessing, that's perfectly fine. But please just tell me what you did, how you imagined, how you guessed, how you estimated, so that I can understand the thinking that went into your process. So the goal here is to compare 2 plants. You want to compare the successional strategies of the 2 plants. So the things that we're looking at in this lab are they R selected, and R stands for reproduction, or are they closer to being K selected, and K stands for carrying capacity. These are 2 letters in the equation that deals with population growth. And so you don't have to decide if it's a K selected species or or an R selected species, you just have to say, okay, well, if K is way over here on this side and if R is way over here on this side, say relative to each other, which one is more R and which one is more K. That's all, just relative to one another. You don't have to decide if it's really a K selected or an R selected species, although you'll probably get a sense of that from looking at the plants. So just to summarize, R selected stands for reproduction. So an R selected species can reproduce very, very rapidly. So they might have explosive periods of reproduction where they just produce thousands or maybe millions of offspring all at once. So they're able to repopulate an area very, very quickly. They also tend to have pretty small offspring and many, many of them. Where a K-selected species, K stands for carrying capacity, and carrying capacity is the maximum number of individuals that can exist in an area without degrading the area in any way. So a K-selected species tends to maintain population size over time. You won't be able to tell that by looking at the plants, but by the reproductive strategy, we will be able to tell. So K-selected species tend to produce a smaller number of offspring more regularly throughout its lifespan. So smaller number of offspring, and usually each offspring is a little bit larger. In the lab guide, we'll talk about all of these details, so it really explains it well, so make sure you read the lab guide in detail. So for the lab report, you're going to just write up a summary of everything that you've learned. So the beginning is just the basic data that you've collected. What are the plants that you've collected? How many seeds do they have? How big are the seeds? What kind of seeds they are? What kind of seed dispersal mechanism is that? And so then you'll take all those facts, all those bits of data, and try to take it and synthesize it and to mean something about the ecology of this plant. So you'll start to connect it to if this plant has the adaptations to be an early succession species, or if it has the adaptations to be a late succession species. And so from that you may also be able to tell if R selected species tend to be early selection or K selected species tend to be early selection. And all that is also discussed a little bit in the Simutext reading, so that should help. Okay, so you'll put together all in a paper that's probably about 3 pages. Feel free to include pictures if you want. And you do have to include a table that just summarizes all the data that you've collected on these 2 plants, and that's described in the lab guide. And I'm having you do a table because I just want to make sure that there's an opportunity for everybody to create a really good table, so you know, so you make sure that columns and rows are all labeled appropriately. You use the word table 1 at the top, and then you put a descriptive caption afterwards. Okay, so that's your lab report. And then the other thing you can do, the last thing, if you feel like you've got time or you're really motivated, is to start on your succession home base. So looking for examples of disturbance. And those examples can be as small as like someone digging in the ground, like digging a hole that's totally disturbing the area, or it could be something really big like ice damage from an ice storm or a flood or wind blowdown, or something in between like a tree falling over. So all of those things change the environmental conditions of the area. It changes the light, the nutrients, the moisture. You know, it can change all kinds of things. So I want you to be just noticing examples of disturbance and then thinking about how those things change the environmental conditions. And then once the environmental conditions are changed, how does that influence the species that are going to live there? So I'll talk a little bit more about the home base next week. But for now, do the reading, do the discussion, and do your lab. And I'll be talking to you online. Have a great week. Here's the barking dog. He can't stop. I think he hears his echo.